Hello, this is Mr. Beth. Welcome to Chapter 8, questions 106 to 111. Question 106. For each quadratic function below, use the idea of completing the square to write in graphing form. Then state the vertex of each parabola. So, part A, we have f of x equals x squared plus 6x plus 15. So I'm going to show this using tiles, trying to write them down so you can see where all of this stuff is coming from. Remember, there are patterns that you have paid attention to that could also help out while you're doing this. So what I'm looking at right now is we have an x squared tile. We have 6 x tiles, which means we need 3 on this side and 3 on this side. And then what is left here? How many 1 tiles are there? And there's going to be 9 because you have x, you split the 6 up into equal amounts of 3, and then that leaves you with the total of 9 units right here. Now you have 15 total, so you have 9 here, and then you have these extra 6 just hanging out that you don't need in terms of the completing the square part. So when we rewrite this, we have f of x is equal to, we're going to write the area of the square, so you have a side length of x plus 3, and there's 2 of them, so it's x plus 3 squared, and then we have the extra 6 tiles that we're not going to use. So that would be in graphing form or vertex form, because we can state the vertex would be -3, 6. On part B, we have y equals x squared minus 4x plus 9. So once again, thinking about your tiles, you have x squared. Now this is a minus 4x, but we can kind of think about it the same way. We have 4x tiles, but they are negatives. And then what does that mean you have here? Well, you have a total of 4 there as well. So once again, you have 4 tiles to complete the square, but you have a total of 9 in the problem. So we have an extra 5 that we're not going to use. Now this side length is x, and these are 2, but remember it was a -4, so really that would be a -2, and then a -2 here. So can we go ahead and rewrite the quadratic in graphing form or vertex form? Well, the lengths would be x minus 2, and you're taking it times x minus 2, so x minus 2 squared, and then once again, we already had 1, 2, 3, 4 1 tiles, or 4 unit tiles, but we have a total of 9, so we had an extra 5 that we're not needing, so we're going to put them outside those parentheses because we're just doing the area plus the extra 5, and that leaves us with a vertex of 2, 5. Alright, let's move on to C. Now C on this one, it looks like we are missing the constant term, which is okay. So x squared plus 8x, once again, to maybe help you with the visual here. So you have your x squared, and then you have 8 x tiles. So you can add 4 on this side, because we're going to split them up, because we got to create a square, and then 4 on this side. And that will leave how many 1 tiles? Well, remember this is 4 x tiles and 4 x tiles, so 4 times 4 is going to give us a total of 16 unit tiles that we need. Well, right now we don't have any. We have 0. So we're going to have to add an additional 16 to this side, and to keep it balanced, we're going to have to add it to the other side. So we're going to add 16 to the left side, but we also have to add 16 to the equation so that we can complete the square. So what does that leave us with? Well, we have f of x plus the 16, and then this is where we now have x plus 4 squared. That's our new square, and then we can now subtract the 16 to the other side. So x plus 4, quantity squared, minus 16, which means our vertex will be -4, -16. Alright, and on to the last one, D. So D, we have y equals x squared plus 5x minus 2. So once again, as you're completing the square, definitely look for patterns that you're seeing to help you maybe not have to do the generic rectangle every single time. But we're going to continue to draw it on here. So that leaves us with x squared I'll draw this a little bit bigger. So we have our x squared tile. And then we have 5 x tiles. So we can do 1, 2, 1, 2. That would give us a total of 4. But we still have 1 left. So we're going to have to take this one and make it a little bit smaller because that's going to represent a half. So this right here would actually be 2.5 on each side. And then if we have 2.5, then what is created right here? Well, once again, if this side length is x plus 2.5 and x plus 2.5, you could try to draw in what's here, which you can see 4 unit tiles, and then we have all these halves going on. So another way to look at that is this is going to be, to find that bottom right corner, is it's 2.5 times 2.5. And that's 6.25. So we need a total of 6.25 of those unit tiles down there. So there's a couple ways we can deal with this. We do have a -2 already on in terms of our constant, but we need it to be a 6.25. So if we need it to be a 6.25, we actually would have to add 8.25, and that would make it a 6.25. That's one way we could handle that. Another way we could handle it is by kind of getting this -2 out of the way by adding 2 to the other side and then just adding 6.25. It'll all work out the same. It's just kind of a preference in terms of how you want to do it. I'm going to go ahead and add 8.25. That way it will give me the 6.25 that I need. So I would have y, and since I'm adding 8.25 to one side, I have to add it to the other side. So I'd have y plus 8.25 is equal to x squared plus 5x, and now I have -2 plus 8.25 is plus 6.25, which is what I need to be able to complete the square. So this would be y plus 8.25 is equal to, now you can see the side length is x plus 2.5 squared, and now I'll have to subtract the 8.25 to the other side. And so my graphene form or vertex form would be y equals x plus 2.5 quantity squared minus 8.25, which means we have a vertex at -2.5 and -8.25. Question 107. Use factoring and the zero product property to solve each equation. So when we're talking about solving for the equation, we're looking for x values. So the first one is already set up in factored form, so we can use our zero product property to set our factors equal to 0. Remember, if two or more numbers are multiplied to give you 0, one of them has to be 0. So that's why we're setting it up, solving solving for each of these. And we get 2 x values. We get x equals 4 and x equals -1/2. And once again, I'll write it in our set notation here, or a solution set, or you can just leave it as x equals 4 and x equals -1/2. On B, we are going to have to factor this one, x squared plus 5x plus 6. So you can use the generic rectangle to be able to do that. Also, continue to look for patterns when you're using the generic rectangle and factoring. You'll start to recognize some things and shortcuts. On this one, we get x plus 2 is equal to 0, and x plus 3 is equal to 0. So we have x equals -2 and x equals -3. So our solutions are -3 and -2. All right, and moving on to the next one, C. C is already in factored form as well. One is a monomial and one is a binomial, but that's okay. We can set both of them equal to 0. And the first one's easy to solve because it's already solved for you. So add the 5, divide by 2, so 5 halves are 2.5. So you either have your solution as x equals 0 or x equals 2.5, or you can write it in a solution set, x equals 0, 2.5. Alright, and the last one, D. Now D, we are missing our constant. So you could use the generic rectangle, or if you look, you notice that we can use the distributive property to factor a common factor out of x. And now it's similar to C, where we have x equals 0 and x plus 4 equals 0. So our solutions are x equals 0 or x equals negative 4. So you can write it like that, or we can write it as x equals negative 4, 0. Question 108. Over a 4-month period, the price of an ounce of gold steadily increased from $1,000 to $1,400. What was the monthly multiplier? What was the monthly percent increase? So we're talking about a 4-month period. So we have, I'm just going to use X and Y. And on the first month, or actually it started at 1,000. So that would be our starting value, our initial value. And then after the next 4-month period, it was up to 1,400. It does say there is a multiplier, so we know that this is not increasing arithmetically or at a common difference. This one is being multiplied. So we can work backwards to see what that multiplier is. Remember, to find the next number, we need to multiply by that multiplier. And in this case, it's going to happen 4 times. So we have 1,000 times b 4 times, or b to the 4th, should equal 1,400. So we can start off by dividing by 1,000. And that would be 1.4, and then we will have to take the 4th root of 1.4. And when we do that, we get b to be approximately 1.08. We'll go 3 places, 1.088. And so the monthly multiplier we found out to be this right here approximately. And then what was the monthly percent increase? Well, remember, we start at 100%, and we just added, in this case, the 1 is the 100%, so we added 8.8%. That's where we get 108.8%. And so therefore the monthly percent increase would have been 8.8% monthly increase. Question 109. Sketch the parabola by using its intercepts. So we're going to work through and find the x and y intercepts. We can start by the y-intercept just because that's the easy one to do. By plugging in 0 for x, everything cancels out except for the constant. You don't really need to show this work, but just showing you why it is equal to 4. So we know the y-intercept is at 0, 4. And then to find the x-intercepts, we need to plug in 0 for y and factor that so that we can find the x-intercept. So I notice there's a common factor of 2. So I'm going to factor the 2 out. And then we can use the generic rectangle or any patterns that we have seen to be able to factor this. And it'd be x plus 2 and x plus 1. And then we can set our 2 factors that involve x equal to 0, because setting 2 equal to 0 is not going to give us any solutions. So subtract 2, subtract 1, and our x-intercepts are at negative 2, 0, and negative 1, 0. And so negative 2, 0 is right here. And then negative 1, 0. So it says to sketch the parabola using only the intercept. So if we do this, we don't know, we know where the line of symmetry is because it has to be in the middle of our intercepts. It has to create that symmetry. But what we don't know is we don't know how far the vertex goes down. So we'll stick to the directions and do what it says and not find the vertex. But finding the vertex would have been a little bit nicer. Or at least it would have given us a better sketch knowing how far down to go. Question 110. For the line with equation 4 times y minus 2 equals 3 times x plus 7, state the slope and the y-intercept. So we probably want to write this in y equals mx plus b form or slope-intercept form. So I'm going to go ahead and distribute the 4 and the 3. And then I want to add the 8 because I want to isolate the y. So we have 4y is equal to 3x plus 29. And then divide everything through by 4, and we get y equals 3/4, or 0.75. x plus 29 fourths. Or maybe you wrote it as 7.25. Either way is fine. We want to state the slope, so we know the slope is 3/4 or 0.75, and the y-intercept, write as an ordered pair, because it does represent a point on the graph of 29 fourths, or like I said, you could do 7.25. For B is negative 7, 2, a point on the line. Explain your reasoning. So to see if it's a point on the line, we can just plug in the point negative 7, 2 in for our x and y. So y would be 2. So 2 is equal to 3/4 times x, which is negative 7, plus 29 fourths. So we want to simplify the right-hand side and see if it is equal to 2. So you could just plug all this into your calculator, or you could simplify it by paper pencil, and that's what I will do. So 8/4 would be equal to 2. So since we do get a true statement, then yes, negative 7, 2 is a point on the line. Alright, so negative 7, 2 is a point on the line because it makes the equation true. Question 111. This problem is a checkpoint for interpreting associations. It will be referred to as checkpoint 8. A random sample of competitive cyclists had their maximum sustained power output, watts, versus VO2 max tested. And the VO2 max represents the maximum oxygen uptake. Their data is shown in the table below. Note, VO2 max is also called aerobic capacity. It is a measure of how much oxygen your body uses when exercising at a maximum effort for an extended period of time. Part A, create a model to find the LSRL, sketch the graph, and the LSRL. So you can see on this one, you're only given the table, so you are going to need the graphing calculator to input the information to find this stuff out. So on part A, you can see the answer key is below. We have P is equal to 3.97 V plus 109.61. That's what you would have found on your calculator, where P is the power in watts and V is the VO2 max. And I had to look up, it has 3 different units there, milliliters, kilograms, and minutes. And I found out that it's measured in milliliters of oxygen used in 1 minute per kilogram of body weight. So, just in case you wanted to know. So then you would create that. And then part B, it says, what power does the model predict for a cyclist that has a VO2 max of 43? That, what I just said a second ago. Consider the precision of the measurements in the table and use an appropriate precision in your result. So I went ahead and set up the equation and plugged 43 in for x because that represents our VO2 max. And we get a value of 280.32. But if you look at all your units of the power, they're all rounded to the nearest whole number. So when we go to write our answer, we will say it's 280 watts. All right, on to part C. Find the residual for the cyclist in part B. So to find the residual, we need to take the actual minus the predicted. And if we do that, the actual for 43, you can see, was 293. So 293 minus the predicted of 280 is not 200. Let's try that again. Is 13, and that's measured in power, which is watts. So you can see that down here on part C. D, find the correlation coefficient and interpret it. So remember, you find that on your calculator as well, and when you found it, it should have been 0.51, which means the linear association is positive, and it is weak because it's not close to 1. It's right in between 1 and 0, so definitely pretty weak on this one. We definitely would like it to be closer to 1 if we're looking at using this as a model. And the last question here, part E, says describe the association, provide numerical values for direction and strength, and interpret them in context. So this is the part where you tie everything together that we kind of just looked at. So it says there is a weak positive linear association, so that we got that part from the correlation coefficient, between power and VO2 max with no apparent outliers. An increase of 1, once again that's milliliters, kilograms, and minutes, of VO2 max is predicted to increase power by 3.97 watts. So that specifically comes from your slope of the linear model. And then your R squared is 26.7%. So it talks about 26% of the variability in the power can be explained by a linear association with VO2 max. So that kind of covers all of the stuff dealing with your with this checkpoint in terms of interpreting associations, looking at the least squared regression model, and interpreting all those things about it.